Okay, in this example we're going to talk about design for additive manufacturing. We're going to validate the part, make sure it's a good part. It's important to remember that this is a plastic part. It's going to be printed in a multi-jet fusion scenario, so it will not need supports. The powder around it will be the supports to hold it in place. But when we talk about these checkers, we'll talk as if possibly supports are needed. Possibly it's a metal print. The different printers that you use and materials might change the different checks that you need to look at. So we're going to go into our design for additive manufacturing tool. And we have all these tools, and we can do things like we can put in lattice and all sorts of lattice for convergent modeling. And we can run checks. For powder bed, might not be laser jet fusion. It might not be too important to have a printhesis, but a printhesis is normally something very, very important. That's essentially your tooling, the direction that the part's going to be printed. So we're going to talk about that. We could put in text, and we could check for things like overhang, because maybe you want to eliminate supports as much as possible. We could do wall thickness checkers, so you can make sure that you don't have any wall thicknesses that are just too small that will not be able to be printed. Minimum radiuses to try to reduce stress and strain. Printable volume, so that, will it fit in the printer? And then if we jump over here, we have more. We have a wholly enclosed volume, so that is it a good part? Will it hold water? If not, then we have a ton of things to fix the parts if they're bad. Channel ratio to make sure that you're not going to be able to have trapped powder inside your channels. Trap supports that you just won't be able to clean out, or at least not that easily, or if at all. And then you could do print time and for overheating. So we're going to talk about some of these, but not all of them. Let's first talk about the wholly enclosed volume. So if we do that, and it already gave us the green check for the part, and we'll hit OK. And wholly enclosed volume, if I hit the plus sign here, you can see that it passed. It is a good part. It will print. If we do printable volume, so let's see if it fits in the printer. Our printer will be, let's say it's an HP demo printer. I have kind of fake printers here, but you would have your real printer. So now it's seeing if it would fit, and obviously it will easily fit, and we could kind of moved it the wrong way. We could move it properly and see that it does fit. And if I hit OK, the printable volume, and it does pass in our HD 3D tools. It tells us that it is a passed part. So those are just two checks. The one I want to run is part orientation. This is kind of like stop shopping. So if I select this and it selects my part, I have to select the printer. I could select different printers, and we'll do the multi-jet fusion. And then I could do the checks that we're going to do. We're going to run for surface area, support volume, and print time. If I go back to the printer and we do a different type of printer, suppose I do the powder bed, and then I look at checks, there's an additional check here for overheating. So maybe for metal, that would be important, because if you have 5 pieces in there, the one in the middle is going to conduct more heat, and there's going to be more distortion. So we're going to go back to the printer, and we're going to check for multi-jet fusion. The checks, we're going to check surface area, support volume, and print time. And then we'll just do the defaults, 45, print time, the layer thickness, and the print time, and then the orientation. So possibly we want to orientate this part in a certain way. We can do this, and then the optimization of everything that we just put in. We'll leave it at low for right now, and we're going to start the optimization, and it's going to run through the inputs that we put in, and it'll give us a different scenarios as to how we could place this in the printer, and we could save the print CSIS. So when we put it in the printer, we could put it in the printer using that print CSIS and having that print optimization orientation. Okay, just finished. It does take a few minutes to calculate that information, and it gives us some information, and we could look at our final output. And with our final output, we have we can select surface area, and we could create our print CSIS there, or we could select support volume, and it gives us different options. Or print time, maybe that's most important to us. You know, we want to print it fast. And then we have different orientations, options that it would, you know, first through 10 scenarios for printing. We'll put it at 1. And then what we'll do is, being we have this and we're happy, we'll save the print CSIS, and there's our print CSIS, and we'll finish the job. So what we've just shown is how to validate the part using our Design for Additive Manufacturing validation tools.